Good afternoon and welcome to B-Sides Las Vegas Lucky 13. You are in Breaking Ground. This talk is titled Cookie Monster, Exfiltrating Data and More, Byte by Tasty Byte. It will be given by Eric Kuehn and Mick Whitehorn-Gillam. Just a few quick announcements before we start here. We'd like to thank our sponsors, especially our diamond sponsors, LastPass and Palo Alto Networks, and our gold sponsors, Intel, Google, and Blue Cat. It's their support, along with our other sponsors, donors, and volunteers that make B-Sides possible. Regarding cell phones, these talks are being live streamed, and as a courtesy to our speakers and audience, we'd like everybody to silence your cell phone if you would. Thank you. If you have a question, use the audience microphone. This is the one I'm holding, so that YouTube can hear what your question was. We appreciate that. As a reminder, the B-Sides photo policy prohibits taking pictures without the explicit permission of everyone in frame. Again, these talks are being recorded, so these will be available online on YouTube in the future. Last but not least, we would like to ask you to please keep your masks on at all times. And with that, let's get started. Please welcome Eric and Mick.
Thank you. I hope everybody's having a good time and as excited to be here as actually Mick and I are to be here talking. We've spoken at other B-Sides, but never Las Vegas, first time here. So really excited about being able to present in front of all of you. So as we said, it's a Cookie Monster, Exfiltrating Data and More. The and more kind of got dropped off. We'll talk about that towards the end. Yeah, kind of dropped off. And this really has been here, it's been like 4 years in the making. We built this utility that we're going to talk about to serve a specific purpose. And then over the years, we thought maybe we should do more with it, back and forth, and finally decided that we wanted to make it publicly available to people. But overall, this tool, while it serves a purpose, it's really more about getting us thinking about our networks, right? As most of the conversations and talks have been here, it's about knowing your network and visibility into your network and what's actually occurring. And that's what this tool is here to help do. Before we start talking about it, a little bit about us. We both work for Secure Ideas. It's a consulting company, security consulting company based out of Jacksonville, Florida. Our CEO, Kevin Johnson, former SANS instructor, started it back in 2010. It's our 12th year. Hard to believe we've been around that long. But we do pen testing, et cetera, right? So what we're talking about is something that we've tested. It's not just us coming up with a theory. It's something we actually tried. My name is Eric Kuehn. I'm a principal security consultant. Before I started working for Secure Ideas 5 years ago, I was responsible for very large Active Directory infrastructures at Fortune 50 companies. Like Windows environments. I know that probably gets me booed off stage when I say I actually kind of like Windows, but I do. And when I'm not working, I'm a movie enthusiast. I love movies. I was actually a film major, acting minor. Love watching movies. Now that my kids are older, we're getting to watch all of the really good movies. It's not just Disney movies, which are nice, but I like action films too.
So I'm Mick Whitehorn-Gillam. I'm from Canada, but I don't live there now. You can probably tell that. I write code. I've been doing it for a really long time. Started when I was 6, basically, on the command line, migrated to batch files within a couple of years, and then actual real programming languages not long after that, and if you can't guess my age, that makes me old. So, yeah. I used to run long distances. Says I do on the slide, but it's been a while.
COVID, unfortunately. I used to lift weights, and then COVID.
Yeah. So yeah, it's harder now.
Yep.
I'm heavier now, because that happens too.
So we're here to talk about data exfiltration. And I'll admit, for us, when we're doing our pen tests, this is usually not something that's on our radar at all, right? Unless you're a very, very mature organization and you have some controls, really, probably all I'm going to have to do is just browse out to an S3 bucket and I can take whatever I want off your network, right? That's not true for everybody. And there's all these wonderful options. Sure, you can use command and control channels, you can use network protocols, FTP, HTTPS, cloud services, like I said, one of our favorites, code repos. Then there's all those physical, I need to move a little further away from you, evidently we'll get an echo. Physical things that you read about that sound so awesome, but I don't think I've ever had to do or probably never will, but using lights on a device and doing Morse code or something strange, or fan speeds or cable harmonics, all this stuff. But like I said, that's really, really high tech and not often what's needed. And I mean, I love my picture there of the monitor on the copier, right, for that physical access in case that's all we have is the ability to print something. And when we're talking about trying to get data off of a network, there's all these controls that organizations are putting in place. There's a considerable amount of time, effort, money, et cetera, all there trying to prevent what we had to do. Our small list, you can limit the open ports, which most orgs are doing. Yep, only HTTP, HTTPS. Although you'll still find even large orgs that somehow forgot about some random port that suddenly you can get access out there that's not covered by a firewall or a proxy.
SMB?
Let's not yet, please no. Although it does happen, SMB, although I've seen SMB in, that's even worse. Let's move past. Then we have next-gen firewalls, right? Seeing what's going on, doing that deep packet inspection, all those intrusion detection and prevention systems, the inspection proxies that are ripping apart everything that we tried to hide over that TLS encryption, right? Let's break that apart. Then you have your DLP software, making sure people aren't opening files that they're not supposed to with credit card information or whatever it might be. Then your drive encryption so that people just can't walk off with your laptop, hopefully. And then, of course, we have NetFlow and other things that are showing what devices are actually talking to and where, right? All of these things that somebody is going to have to try and defeat. Of course, once again, if you don't have all of these things, maybe having somebody try and exfiltrate data should not be one of your top priorities. But that's what we were trying to solve way back in 2018. Hard to believe it's been 4 years. We were actually doing a red team assignment, different from what we typically do. We're pen testers, but we do red team as well, right? Pen testing, if you're not familiar with the difference between red team and pen testing is down and dirty. We have like this much time to get wherever you want us to get to. Red teaming, we're going to try and be really stealthy. We've been on the network for a while, and our problems really came down to that last bullet point. The blue team was really responsive. You messed up at all once, and they were on you. We made a small mistake on one device trying to test a website to see if we could get a phishing campaign to work. They caught it. That domain was burned. And I'm sorry if I'm echoing. I don't know what I did wrong. But our client wanted us to exfiltrate data, right? They had these controls. They only allowed HTTPS out, not even HTTP. They proxied everything. They were ripping everything apart. They were inspecting it. They limited where we could go, right? We had very limited domain options. Content filtering, DLP software, everything. We knew that they were ripping the traffic apart, but we couldn't tell what they were using, right? And they wanted us to get this file that they gave us that was full of credit cards and other sensitive information and see if we could get it somewhere. We didn't want to try the good old S3 bucket. They weren't using the cloud. It was 2018. This institution hadn't moved there yet. And we knew we had one shot. So Mick, myself, and another gentleman were sitting around. We're discussing. We're like, what are we going to do that might mask this and let us get some data off of this network? We need something that's quick. We didn't have a lot of time. We're getting towards the end of the engagement. And we need something that's low tech, right? We don't want to invest the time and effort to try and get one of their devices to do some strange harmonics on a cable or something. So we actually said, what's normal in web traffic that's there that probably isn't going to be looked at by anything? And that brought us to cookies.
Right, so just to do a quick overview, because people are at different levels with cookies. Most people, probably, if you deal with HTTP traffic on a regular basis, this is going to be, well, why is that guy explaining cookies? But for the people in the audience that might not, so example there, that's a request, there's a cookie in it that's being sent to the server. In normal traffic, that would be set one of two ways would be common. So either a response header would have come back that said set cookie and provided the value, or a response of some other kind, like a JSON response would be a common one, sent the value back, and then JavaScript on the page picked it up and shoved it in through the browser's API. Those would be the two ways they normally would get set. And then when the requests go to the server, whatever the scope is for the cookie. Those cookies get included in a header just like in the picture there.
And the important part is, as you see from our website, Secure Ideas, right, it's pretty much unintelligible, right? There's nothing there to give you any indication of what it is. And if that's what a system is looking at to determine if this is normal behavior or not, we were pretty sure we could do something that would look kind of like that and bypass all of those wonderful controls, which brought us to Cookie Monster. So cookies have a max size, right? You can't just send that whole file all at once. It's going to be way, way too big. So we said, let's come up with this idea. Let's encode the data, take that file, just encode it, read everything, read the contents, encode the contents, break it apart into nice sized chunks, send all of those out in requests as cookies, merge it all back together on the back end, bam, we have our file, right? And of course, we needed a mascot. As soon as you build a utility, if you don't have a mascot, it's not a utility, right? Okay, so Cookie Monster v1, back in 2018, built on Node. We had a web server. In our case, it was Apache because we wanted to have that TLS encryption, just because we didn't want to send anything over HTTP, and it wouldn't have worked anyways through the proxy. So we had the cert. And then we had the feeder. The one thing that we found on their network, which was very nice for us, it was 2018, so PowerShell was still a very good attack vector back then, right? Not quite as good now. We can have discussions about that. I think it's still a good attack vector. But PowerShell was enabled. We could use it. So we built the feeder, the script, around invoke web request. This is sending, just like it sounds, a request as if it was like a browser to a website. So we encoded the file in memory. All right, took up a little bit of space. We used that normal commandlet to bypass them if they were looking for something using a .NET library, because that is a little odd in most cases. We made sure to set the user agent on the request, so it didn't say PowerShell, right? That would be kind of obvious. And then we also said, let's allow it to send a whole bunch of files, not just one, and then put that random sleep in there so it's not just sending request over request over request. Let it take some time somewhere between, like half a second and a minute, whatever you want, to make it look a little odd and not sit there and be a consistent state. It was simple, but effective. And you look at that, and it looks very different from our cookie. And I'm kind of embarrassed to say that this is what we came up with, but we were running out of time. And the funny thing is it worked, right? This bypassed their content filter, their inspection proxy, everything. To us, any person looking at it who has any idea what a cookie looks like, this looks pretty odd, right? We've got double slashes in the front, and that was because we were encoding certain things. We didn't want it to be able to see it. That's not normal. We have some random integers in there that were telling Cookie Monster, the backend, hey, this is part 1 of X. So that incremented. And then we had our payload, which is the first, that was part 1 of the file. And then we had some other bad things in there, right? The web server did things like said, okay, whatever. But overall, it worked. If somebody would have seen this while we were going through the 45 minutes or so it was sending the data, they would have instantly known it was wrong, right? If they would have gone to that website that we had picked when we got that domain name, it would have errored because it didn't have cookies. It was down and dirty, but it worked. It's not good enough. We know it's not good enough, right? That was like Gen 1. Let's do a proof of concept. We needed to be better. We needed to be hiding in plain sight better than we were.
This is a picture of a snake.
Do you see the snake? No? She's right there. Do you see him?
It's a copperhead.
Okay, can you see him now? That's the nope rope. That's the bad end of the nope rope. You don't want to get bit by. It would be really, really bad, okay? This is one that Mick saw when he was running.
That's not true.
Yeah. This is what we needed to be. We needed to be like this guy. So we came up with version 2. We said, all right, let's take a step back. We want to stick with our same premise, but things have gotten better, right? We're sure detections have gotten better. So let's set up some other stuff for us. Number 1, let's set up a unique ID for our device, because before it would accept, like, if we had 4 computers all sending files at the same time, it was going to get confused really fast. So let's add a unique ID. Let's do some better padding. Let's get rid of that slash in the front, right? Let's do something a little bit better. Do some graceful handling in case the server goes offline or something strange so that we can do some retries. Because when you encode the contents of a file and you miss a section, you pretty much lost everything. Mick made a beautiful UI, all right, a functional UI, and a whole bunch of other enhancements, and then we put it on GitHub because, well, once again, we think this is going to work. I admit, we don't know if this version is going to work. So when we get to the question time and you say, is that going to work? We're going to say, maybe. We have no reason to believe it won't, but we admit, as of right now, no one has paid us to try and exfiltrate data out of their network. If you're interested in helping us test this, please let us know. Reach out, right? We'll be happy to do it.
Or if you test it yourself, let us know.
Or test it yourself. Let us know. We want to know. So the server enhancements, all on Mick.
Oh, that's right. That's me.
That's you.
I rewrote it, like pretty much the whole thing. Updated it to Node 18 is what I was using, but it would probably work on 14 or higher. I did stuff. So user interface is there. It still doesn't have built-in TLS, but we do that through a reverse proxy. Definitely, if you're using it for real data, even in a testing environment, be nice and TLS encrypt the data. Keeps a lot of stuff in memory at this point in time. When Eric wrote that bullet point, that's because that's what I told him, but it's not actually entirely true anymore.
Oh, I need to change it? All right.
It does write a temp file at one point. But yeah, so it still reassembles, still decodes, and it can send one command, actually. It can send, am I premature on this?
Well, go ahead.
It can send one command to the server. It's kind of hard-coded in there. It's who am I. So you can send who am I's up to the server.
Yep.
We didn't really want to push out a full C2 framework because, ethical concerns and all that. So we did it that way because that way if anyone uses it, they'll probably get detected.
That's right.
Hopefully.
Because everybody knows who am I is the immediate notice that you've been compromised, right? Who am I equals you're in trouble.
The only people that don't know who they are people that don't belong there.
So the feeder, still using PowerShell. I like PowerShell, right? Windows guy, I like PowerShell. I know it's protected, right? You can do all sorts of things to see what's happening if you've turned on the logging and everything else. Many organizations still haven't. It's a little bit more customizable. You can set any user agent you want. It has a default that looks like a Windows 11 box. You can set it to go through your own proxy. You can reconfigure the cookie size to be anywhere from, well, pretty much anywhere, but you don't want to go over 4,000 bytes, I think is the limit. And now it adds some other things in there, right? It goes to a random page itself. It kind of picks some random page to send you to. And it has that heartbeat option. And yes, we did originally have the idea that we wanted to accept commands and do functions based upon commands, but that was a little bit more. We like the idea of this being a way of testing your exfiltration controls right now more than a command framework. It probably could be expanded out, but we'll let that up to you if you want to do it. So now everybody needs to, like with me, hope, please work that the demo is going to function because as you all know, they never do. But hey, we'll see what happens. All right, no, minimize. Thank you. All right, so here we go. Here is our file of credit cards. I don't have DLP on my box, right? But we'll assume we got past it. Just random credit card numbers. And just to show that it's a new thing, where are we? We're in BSides, Las Vegas. All right. So, over here, we have our feeder. So it's a simple little UI. Can everybody see it? Here, let me make it a little bit bigger here. There we go. So, you can change a couple of settings. You can add some things.
Oh, we're out of frame.
We're out of frame. Sorry. But I'm going to start the server. And so over here, we can look at the PowerShell if we want. I just have my simple little script. It says invoke the feeder, Cookie Monster feeder, give it the URL I want to go to, the base URL, a proxy because I want to send it through burp so we can see what it looks like, and the file name. And now everybody crosses their fingers. Hey, all right. We are successful. It worked. At least it started. So here we go. We can see that it's getting data. And if we look in burp, right, it's sending us to random pages. And to top it off, the server is responding back with data, right? Yeah, this is a big win. It's not just something, that says hi. Yeah, it's a small selection. You could put more in if you want, but it's our small selection. And it's running through. You can see it's doing all the gets. We have it doing a get. It'll do any web method you want. What we found is, MITRE and many of the other groups that are seeing how data exfiltration happens, it's via posts. So if that's one of the things your data exfiltration is looking for, it's not going to catch us because we'll do a get or a put or whatever we feel like. A delete, it doesn't make a difference.
A trace, or we can make up our own method.
Yeah, whatever we want.
Yeah.
And we can see, here we go. The cookies look a lot better. That looks a lot more normal, right? Like a cookie. And that has everything. So we also included, we decided that our identifier should be like a Google identifier because everybody's using Google for tracking their website. So there you go. So that identifies the box. We still have our session data that's holding it, but we added a random letter in the front, all right? So in theory, my file is sitting over there. I'm just going to SCP to the box to grab my file. Oops, helps if I change the IP address. All right. And in theory, if this worked, there's my new file, the exact same one. Woohoo! It worked. Oh, always a good day, always a good day. So, but just to show in case you wanted to do the other thing, we have this other option for you. So now, Cookie Monster is running in the background every 30 seconds, or if you wanted to change that, he goes out and he just does a quick heartbeat to the server. And we can see there he is. That should match him, but I'll trust it matches him.
It matches.
And there we go. We're going to do the one command, your who am I. And then we just sit here and we wait. And we'll go back to burp. There was the response back from our server saying, hey, please do something. So we said set the cookie. My server and Cookie Monster responded. And there you go. Right? So, normal web traffic. It looked just like web traffic. Once again, we set this up just to do this one method, right, using PowerShell. It doesn't need to be PowerShell. It could be anything you want. All right, so let me go back so I can.
Right. We didn't really explicitly call it out there, but so a lot of people probably recognize that cookie was base64 encoded.
Yeah, thank you.
We threw another character on the front of it, just a random character that we ignore, but it's enough to throw off the padding of the base64. So if you grab the whole thing and decode it, it looks like junk.
Yep. So if you just grab the actual encoded part, you're good. But once again, we're not trying to defeat people, right? At no point am I trying to defeat a real person who's looking at this. Because if your job is to be looking at every single web request going out, that's a really bad day. I'm sorry for you, right? We have systems that do this, and we just need to defeat that system. So, pros and cons of Cookie Monster. Pros, standard high-use port, right? Web traffic happening all the time, everywhere. It runs as any method. We could make up anything we want. Once again, it doesn't care. It's just running in the background looking for cookies, right? The cookies are, once again, cookies themselves are typically encoded or encrypted or some random stuff that isn't going to be inspected or useful. Cons. There are cons. You can't make a perfect tool, unfortunately. It requires a lot of web requests to send a message, right? Depending on your file, simple math, if we're only going to send 500 bytes at a time, you're sending a 1 gig file, that's going to be a lot of requests. We admit that. But once again, you could space it out over a long period of time too. You don't need to send it all at once. It can make some files bigger, because encoding things, the data of it, it could make it a bigger file than what it was originally. And then, of course, you have to host it somewhere. So if they have some really good content filtering or based on reputation filtering, it may not work. But it's there. And once again, we know it's listed in MITRE. It's listed in other places. This is an attack that is known. We just tried to tweak it a little bit and pick an area that might not be used. Setting a custom server header is easier to pick out than trying to inspect cookies. I don't know why a real legitimate detection system would be trying to break cookies apart, but there could be a valid reason. And then once again, your max size is just over 4,000 bytes, because that's the biggest you can actually set with a cookie, or the entire...
It's the entire header.
Yeah, header and everything breaks.
Yeah, but that would look weird, too.
That would also look very weird, so yeah, please don't send it that big. So where do we go from here? Well, you know, we think more feeders would be good, not just PowerShell, Python. We've talked about it. Why even limit ourselves to just a programmatic way? Let's build an actual website that's just sitting in the background looking for the cookies, and then you can browse there yourself and just send the data, and it looks 100% legit, because I'm not actually going to move even as fast or as normal or repetitive as something with a sleep.
Or you upload an HTML file on it. I'm relatively confident I could implement that feeder in the web browser.
We want to enhance the server some more. We want to store the information somewhere in a little bit better. We still need to work on breaking it apart by device. We have some potential limits there. Even better disguises, because we know we can have them. Better web pages, like we said, better things to see.
Yeah, so a couple options I floated around there, where one would be use an interception proxy to collect a bunch of responses to then pass the project file in there, like a burp project or a OWASP zap project, or proxy it and actually point it at live sources and get your responses from there.
Yep, just forward them on. Perfect.
Yeah.
Better obfuscation, redirects, et cetera. We want to have other encoding options. Why limit ourselves to cookies? Let's use JWTs, right? The signatures in the JWT, that is 100% unreadable. It's supposed to be.
It's always opaque anyway.
Yeah, it's always opaque. I mean, that would be incredible. We just didn't have time to do it. Do some iterations of encoding. Have the server actually dictate the cookies. Because right now it's hard-coded in both, right? So this Cookie Monster, first thing before it sends a file, goes out and says, hey, what should I do? We get the cookies back to actually look like the server is setting some cookies. All sorts of things. Oh, and let's actually have the ability to have Cookie Monster tell the feeder to stop doing the heartbeat. That would probably be a good thing to add in there.
Yeah.
And you know, then we have these other questions. Like we said, the whole command and control framework. Is that something we want to get into? I don't know. We think, once again, we think it would bypass it, but I don't know if that's something we want to be responsible for. You know, people have written command and control frameworks and they're like, this is awesome, let's release it to the world. Oh boy, what did we do, right? That might not be where we want to go with this. So, what's the point of talking about this awesome tool other than saying, hey, we think we made this awesome tool? How do you detect or prevent it? Well, all right, so you're going to have a large number of requests going to a single source. Or will you? Why not have like one central server just getting everything from a whole bunch of websites that you create out there? That's going to mask it even more. All right, so maybe that's not a good one. Reputational-based filtering, yeah, that'll work. Oh, wait. All of the people who do the reputational-based filtering will be more than happy to tell you the web domains and what their reputation is right now. All right, and it's easy to find domains that are expiring. Okay, so we can't use that. Sending cookies without getting it from a server. Okay, that's pretty strange, except all of the websites that say remember me forever.
Yeah,
Okay.
Because of long-lived cookies, it wouldn't be that weird to see traffic today that you didn't see a set cookie for, so.
Yeah. Let's see, cookies being rotated without the server, yep. The endpoint protections and heuristics, absolutely, but as we all know, those You don't want to put all your cookies, in one basket, right? Or all your eggs in one place. They can be broken, and let's face it, that may not actually catch it, depending on what's going on in the background. It all comes down to what everybody's been talking about, like all the keynotes and everybody. What's normal in your environment? Where are people talking? Where are they suddenly going that they weren't going to before? That's what's going to detect it, right? Knowing that level of information. But maybe we missed something, right? Did we write a utility that nobody needs? Did we solve a problem that didn't exist? Anybody have any ideas? I think we came up with something different and something a little unique, a new take on stuff. How would you protect against it in your environment? That's why we came to Breaking Ground, right? We're like, hey, we think we have something. We thought we've come up with ideas to break all of the ways that a system is going to try and detect it. What did we miss? Anybody have any ideas? If you have a question, let us know, right? We're here because we want to get your thoughts. Know who's using that sensitive data, where it is. Don't let it float around. And that's it. So we're really early. We'd like questions. Or we could go through the demo again and watch it break.
Since we have the GitHub repo on there, I just want to say there's some really bad code in there.
Fair enough. And I'm gonna repeat that. I said I was a Windows guy. I can write PowerShell. That doesn't mean it's good-looking PowerShell. It's functional.
It works.
But it's not good-looking.
So Eric has an excuse. I know better. I run a dev team, and I told my developers, don't write stuff like this. We will have a hard conversation if you write stuff like that.
Yeah.
It works. It's not pretty. It needs a lot of polish.
But it's there. It's based on an idea. We know it worked 4 years ago. We think it's going to work even better now. We'd like to know if it does for you, if you ever give it a try. Any questions? Please give us questions.
Yeah, I've got the microphone here. If anybody has a question or wants to try to answer the question they had at the end about how you would prevent against this, I can just raise your hand and I can bring the mic over.
Please give us something.
Coming from the back.
Came all the way from the back. So one question I have is in your previous slide, you had sending cookies without getting them from the server, cookies rotate, being set from the server, or stuff like that. So I mean, to me that sounds like maybe a spec change on the HTTP side, to deal with that, because implementation in the browser. But a question I have, and this is the question: what in your research is anyone else legitimately rotating cookies or setting cookies without receiving them first?
So,
is there any false positives we might get based off of that?
So absolutely, the seeing a cookie being sent before it was set will absolutely happen, right? Because, okay, let me take a step back. If you're sending all of the traffic from your devices all the time through the proxy, even when they're at home and not VPN'd in, okay, then that would probably be pretty rare. But how far back are you going to take that data set, right? How long do you say, did I see that cookie a minute ago? Or did I look back a month ago, right? Because, websites, remember me forever. So absolutely, the looking for a cookie being sent before it is set by the server would give you false positives. The rotating.
That would be weird.
That would be a weird thing.
That would be uncommon.
So, yes, we do admit that is a limitation. So.
I think I saw another hand over this way. Awesome.
Hey, just like to say, really awesome tool so far. I love it, man. My question was, when you said you have the reverse proxy handling, say, TLS connections and whatnot, do you have kind of a fear of being fingerprinted using JA3? Because I know ciphers and things that are offered to clients are being fingerprinted now. Like, I don't know if it's on the internet, but JA3 is a way to fingerprint C2 frameworks and certain endpoints based on the offered TLS ciphers and whatnot. Is there any changes that have to be made to this framework specifically to accommodate, randomizing that, or is that more on the proxy side?
No. So if you get the certificate from a legitimate source, right? We're not using it for the encryption of the program. We're just using it as a normal TLS encryption, if I heard your question right. So the question was, do we need to compensate for specific ciphers or anything as far as going out and being used for the reverse proxy, correct?
Yeah, it was more so just will you account for being fingerprinted by offering the same TLS ciphers over and over after each deployment of the tool?
So if we would stand this up in multiple locations, or we'd stand it up again, and like we use Nginx is what we used. If we've got a cert for that server, it would be one, right? Whichever website we decide to stand up at the time to host Cookie Monster could have a new certificate. So you'd go through the renegotiation as necessary, but once again, it doesn't need to be the same certificate everywhere.
Okay, cool, thank you.
Yep.
I think if I wanted to make it distributed, I'd probably stick it in there as an endpoint behind a bunch of like CloudFront instances or something like that.
Yeah.
Who else has a question?
Up front. Anybody have a better way of detecting it? Come on. I know there are a lot of smart people in this room. I know you're smarter than me too.
Yeah, like I guess if you wanted to add like more obfuscation techniques to it, or maybe make it so that there's not so many patterns, would it add too much complexity if you had like well, I know that there are a lot of links that have like really crazy parameters, or like when you visit Google, sometimes you visit a website, it has like a bunch of like garbage, what look like garbage parameters, and it looks like a really crazy link. So I'm wondering if you do obfuscation and maybe throw in some parameter and use that to alternate the obfuscation, would that add too much complexity to the project?
We could. I mean, we absolutely could have it send parameters. It would not add that much complexity to what we're doing, or having the web server respect it, right? It's just extra development programming.
Yeah, I don't think that would be difficult at all.
So,
No. To add
yep.
some kind of generated parameters in there.
Right. We actually just don't want to send any real data through it, right? The whole idea is to keep all of the important data stuck in the cookies.
Cool. And would it help at all, like, to kind of alternate the obfuscation technique you're using in the cookies?
Yeah,
Possibly.
possibly.
Yeah.
Like we said, talk about JWTs is the way we definitely want to go next.
Yeah, JWT signatures would be a neat hiding spot. You could do possibly some like base64 encoded image uploads. You could stego it in there. There are options. There are a lot of ways to go with it in terms of more variety. And another simple one would be to just renegotiate what names we're going to use for the cookies periodically, so that they're not always the same cookie names. Those could also change. You get Sessions are common. JSession ID is another different common name for a session cookie, but it doesn't even have to be either of those. It could look like a cognito cookie. Yeah, lots of options.
Yeah, you mentioned one of the drawbacks of the tool was that the data would be going out to an unknown host, right? And obviously setting something up at the last second as a destination is risky. And I've been in situations where outbound proxies are incredibly, extremely stringent. I mean, have you done much research on like anything with like legitimacy you can hijack, like a Google Sites or like an old defunct cert you can renew yourself? Yeah. I mean, maybe outside of that part, but like any.
Yeah, I mean, so extensive research, no. I mean, when we need a site, we have our places that we go that list recently expired sites. You can check those through any of the tools to say, what's your reputation? Do you have one? Right, they provide it for you. So beyond that, no, I have not done extensive research into using this specific item or one that will absolutely beat this utility versus another.
Hey, I have two questions.
Sure.
The first is, have you thought about using WebSockets to create that connection and send the information
That's
that
funny.
way?
We actually
because then
did-
it's like a continuous connection?
We actually did discuss that. And so we went back and forth. We think it could work, but would that be inspected more than not? So that's it was one of those takeoffs and something we debated of potentially doing.
Yeah, it really came down to we were afraid that would look more suspicious to somebody watching.
Which kind of feeds into the next question, because if that is the typical way that client communicates on the web application, could you take that into account and maybe, first of all, clone that way of communicating via WebSockets and use that as the base for your communication? But then also, could you take the cookies they typically send on their applications and then name them accordingly to then bypass any filters that might come on to the names of the cookies from before.
Absolutely, right? If we wanted to, once again, we get to dictate whatever we want. The whole idea is, as long as what I am sending is understandable by the server, it doesn't make a difference, right? So we could pick up the cookies. If we found a website that we really wanted to clone, we could, right? Assuming it had the right number of cookies in it for us, which is 4. Right now, 4?
Or more. It
Or
could have
more. So we could. But then, of course, then you have the other problem of, hey, that's saying that's rsa.com, but it's not, right? So I'd rather go and pick up my sites now, like my 5, 6 financial sites that have expired or whatever, rated, sit them up there, put up a good website that says coming soon, and then when we need to exfiltrate data, we just throw Cookie Monster in the back end, right? And it's waiting there, ready.
Cool, thanks, really interesting. Also, the idea of a C2 server sounds really interesting with this as well, so, but risky.
Exactly, that's where we were. We're like, this would be awesome because, I didn't say it, I have a hate-hate relationship with Metasploit and many of the other frameworks out there. I will type something and say go, and I get that horrible exploit ran, but session failed, whatever. A peer of mine, Nathan, would go up there, just hit enter, and it works, right? So me, no, bad. I'm not good with C2 frameworks. I like living off the land.
Who else has a question? There we go.
Hey, thanks for the talk. Quick question. So you mentioned that the file you're trying to exfiltrate, it'll break down and have like an ID as part of like each request going through, right? So the file's split into smaller sizes.
Mm-hmm.
If you're exfiltrating a large file and maybe some of the requests time out and they don't send those chunks, can you from the server side just say, hey, request part 5 or something?
So yes, and so there's another part that we started. We went down that path of, hey, had the server tell me it failed or not. And what we decided instead is to just, we're doing it sequentially, right? So server goes offline, the feeder pauses, tries, and once it gets a good message, it'll continue again. We did discuss the whole, let's send a final ACK and do everything. It just came down to time before we got here. We do pen testing a lot, and this was a side project for Mick and I.
That was,
Yeah, that makes sense.
that was the scope creeping on me because I decided to rewrite a thing.
Yeah, rewrite a thing to do a thing.
Yeah.
And so we did change, and so let me find, I've been heart beating in the background as we've been talking, so let me find somebody. So we changed the entire mechanism, right? This ITN there. Oh, you can't see it because I'm not sharing the screen. This entire ITN there is actually the encoded, you know, this is part, we have 28 parts, this is part 2 or whatever. So it still gets that information. It's just encoded in a better way.
Okay, cool. Yeah, I mean, my main thing was like, obviously, if you're exfiltrating a large file and it fails, you don't want to repeat the entire process all over again. So just be able to say, oh, I'm missing this part. Can I just request this only?
Yep, that is definitely something that we've talked about. And so it would be a good addition to put in just time.
All right, thanks.
Yep.
Any other questions? Make sure I'm not the one in the front.
Hello, I wanted to ask one thing. I suppose this is quite stealthy on the network level, but what about the detection when you have like Windows Defender and you're doing the base 60 for encryption or use the invoke web request functionality? Does this get detected a lot, or what's your experience with it?
No, by default, okay, so as of right now, the feeder has not been submitted to anything that's saying it's malicious. That could change, and then it would, right? And then Defender's going to pick it up. But the behavior that we are exploiting underneath the hood, no, it's invoke web request. It is an expected behavior of PowerShell. We are doing nothing malicious at all, right?
Yeah, it's not malicious, but I think nowadays when you're base encoding, for example, or when you're using the invoke web request, it sometimes gets flagged because it's unusual activity, and
So-
it might.
Yeah, so if you have the full Defender suite, identity and all cloud, it very well could. I can't speak to that. the default Defender endpoint protection on its own isn't going to care. Does that?
Okay, thank you.
Yeah.
Any other questions, thoughts?
Is anybody going to download it and try it? Awesome.
Who's going to download and try it? There we go.
All right. Eric at securideas.com, Mick at securideas.com. Let us know, all right? Not a difficult email address. Please let us know how it goes, because we only get to try it when somebody pays us to. So,
Awesome.
thank you very much.
Guys.